In this video, I'm going to cover two more rules for finding the derivative. We've already spoken about the power rule, where you can find the derivative of a function that has terms combined with each other by addition or subtraction. This video is going to cover the product and the quotient rules, so you will be able to find the derivative of a function that has factors and a numerator and a denominator. I'm going to start with the product rule. And the product rule, just like the quotient rule, is going to assume that f of x and g of x are differentiable. And differentiable just means that they actually have a derivative. I'm going to write the product rule out three ways. Two ways use notation for the derivative, and the third way is just in words. So the first way, we're going to say we're going to take the derivative of f of x times g of x, where f of x and g of x represent two factors in a product. You're going to have the first term, which is f of x, times the derivative of the second term, plus the second term times the derivative of the first term. This rule involves multiplication, so this first piece here has two things multiplied together. This also is multiplication, and then we have addition in the middle. Multiplication and addition are commutative properties. So the order is a little bit flexible here. You can reverse the f of x and the g of x here in this first term, and you can reverse the g of x and the df dx in the second term. And the plus sign allows for the right and the left to be reversed. So there is some flexibility with the order. If we write this with prime notation, it will look this way. We're going to want to find the derivative of f times g, so f times g prime. Following the same pattern as above, we have the first function, so f times the derivative of the second, f g prime, plus the second times the derivative of the first. It's a little bit less cumbersome than the first notation. And then lastly, in words, it goes this way. We're going to have the first function times the derivative of the second function plus the second function times the derivative of the first function. Being able to recite the power rule in words is really helpful as you work through the problems. Let's try a couple of examples. Keep the rules in front of you so you can follow along. Y equals the quantity 3x squared plus 2 times the quantity 5x plus 8 This is a product. We're going to have our first term is 3x squared plus 2, and the second term will be the 5x plus 8. Using the first notation that I wrote out, y prime equals the first term times the derivative of the second term plus the second term times the derivative of the first term. In this line here, I actually have not taken any derivatives. All I have done is filled in the information into the formula for the product rule. And I really suggest you do this until you know the rule and you're really comfortable taking derivatives of the individual pieces. Now we're going to go ahead and take the derivative. So y prime equals 3x squared plus 2. The derivative of 5x plus 8, so this is the power rule now. The derivative of 5x is 5. The derivative of 8 is 0. Plus 5x plus 8 times the derivative of 3x squared plus 2. So the derivative of 3x squared is 6x, and the derivative of 2 is 0. Now all that's left is to simplify this. So you have to multiply together what can be multiplied, and you have to collect your like terms, and you do have to simplify this. Y prime equals, using the distributive property, 15x squared plus 10 plus 30x squared plus 48x. And collecting up our like terms, we get our final answer. Y prime equals 45x squared plus 48x plus 10. And this is our derivative. Now if you go back up to the original line where I just had y equals, this is a product that is easily multiplied out. So there was actually another option to do this. I did it using the power rule so I could demonstrate how that rule works. But you certainly could have taken the time to multiply this out, and if you did, using FOIL, you would end up with 15x cubed plus 24x squared, let's go back, 15x cubed plus 24x squared plus 10x plus 16. And if you take the derivative of this, one term at a time, you end up with the answer that we have down here in the box. The derivative of 15x squared, 15 times 3 is 45, and then we have x squared. Sorry, the derivative of 15x cubed. The derivative of 24x squared, we get 48x. The derivative of 10x leaves us with just 10, and the derivative of 16 is 0. So you can see that you could get the same answer if you took the time to multiply this out and simply used the power rule instead of the product rule. Often there's an option. You can choose how you want to do it. Sometimes the product is complicated and it would be easier to use the product rule than to multiply it out. And you'll just have to make a choice problem to problem. Let's do one more example of the product rule. Y equals, I'm going to switch back to black here. (4x squared minus 1 times the quantity 7x cubed plus x. The product rule reads, we're going to take the first term, 4x squared minus 1, times the derivative of the second term. Again, I'm not taking any derivatives now. I'm just filling into the formula. So the derivative of 7x cubed plus x plus the second term times the derivative of the first term. Now you go ahead and you take the derivative of the quantities that you need to. y prime equals 4x squared minus 1. Go ahead and take the derivative of 7x cubed plus x. You're going to write that down next. You should have 21x squared plus 1 plus, and then you have your term here, 7x cubed plus x. And now go ahead and write the derivative of 4x squared minus 1. That derivative is 8x. And just like before, the last part here is to multiply, FOIL this together here, use the distributive property over here, and collect up your like terms. I'll give you a minute to work through that, and then I will give you the answer. You should end up with 140 x to the fourth minus 9x squared minus 1. Okay, let's move on to the quotient rule. And just like with the power rule, f of x and g of x are differentiable. I'm going to add here that g of x cannot equal 0. You're going to see that g of x is going to represent our denominator. And again, I'm going to write the rule 3 ways. Twice with the notation and once verbally. This time we want to take the derivative of the quotient of f of x divided by g of x. And you can see now why g of x cannot equal 0, because we cannot have 0 in the denominator. The rule reads this way. We have the denominator, which is g of x, times the derivative of the numerator, which is f of x, minus the numerator times the derivative of the denominator, all divided by the denominator squared. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. In the numerator here we can see that you use subtraction. Subtraction is not commutative, so there is no flexibility in the order in which you write this out. Using the prime notation, what is the derivative of f over g? So in other words, what is f over g prime? Using the same pattern, we have the denominator, which is g, times the derivative of the numerator, f prime, minus the numerator, times the derivative of the denominator, which is now g prime, all over the denominator squared. And lastly, written out in words, and again this is probably a very useful thing to know because you will recite this as you work through the problems. You have the denominator times the derivative of the numerator, I'm going to have to abbreviate here, numerator, minus the numerator times the derivative of the denominator all over the denominator squared. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. All right, keep these in front of you and let's try an example. Here's our function. Y equals x squared minus 1 divided by x to the fourth plus 1. Now let's find this derivative. This requires the quotient rule. This numerator and denominator cannot be simplified at all. Y prime equals, according to the rule, we have the denominator, so x to the fourth plus 1, times the derivative. I'm not taking the derivative, I'm just writing it out that I need to take it. The derivative of the numerator, x squared minus 1, minus the numerator times the derivative of the denominator all over the denominator squared. Now we can take the derivative of the two terms in the numerator that we have to. Y prime equals x to the fourth plus 1. The derivative of x squared minus 1 is simply 2x minus x squared minus 1 times the derivative of x to the fourth plus 1, which becomes 4x cubed, all divided by x to the fourth plus 1 squared. This up here should say x to the fourth. Now it's a matter of simplifying. So we have to multiply out the numerator. The denominator right here, most times this is left alone. You will not FOIL this out. You will just leave it as the quantity x to the fourth plus 1 squared. All right, let's work on the numerator. Y prime equals, distributing the 2x over the two terms in the first set of parentheses, you're going to have 2x to the fifth plus 2x minus, and be careful, there's a lot of signs to worry about here. I'm going to open another set of parentheses. X squared times 4x cubed is 4x to the fifth minus 4x cubed x to the fourth plus 1, the quantity squared, still in the denominator. And one more line to simplify. This minus sign is going to distribute across the parentheses. So we have a 2x to the fifth minus a 4x to the fifth, so that's a negative 2x to the fifth minus a negative 4x cubed is plus 4x cubed, and then plus 2x divided by our denominator. And this is our derivative right here. So again, plug it in to the formula. Don't take the derivative right away. Wait until you get to the second step. Leave your denominator most often untouched, and then use your basic operations and properties to simplify your numerator. Let's try one more quotient rule. Y equals negative 9x plus x squared all over 7x. Now, this is a quotient where you could simplify. Unlike the first one, which could not be simplified, we could simplify this one. But I'm going to use the quotient rule, so you have one more example of use of the quotient rule. Y prime equals, reciting the quotient rule, we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Now let's take the derivative. Y prime equals 7x the derivative of negative 9x is negative 9. Then we're going to have a plus 2x minus negative 9x plus x squared, and the derivative of 7x is simply 7. And now we have to simplify. Y prime equals 7 times 9 is 63, so we have negative 63x plus 14x squared. 7 times 9 is 63, so we have negative 63x, but we also have the minus sign that connects the two terms, so we end up with a plus 63x. And 7 times x squared is 7x squared, but minus 7x squared by distributing that minus sign. Now this denominator actually can be simplified. 7 squared is 49, x squared is x squared. The 63x's are going to cancel. 14x squared minus 7x squared is 7x squared. Over 49x squared. And simplifying that, we get 1/7. And this is our derivative. This quotient could have been simplified. I'm not going to do it the second time, but certainly we could have done this. Negative 9x over 7x plus x squared over 7x. Simplified this, so negative 9/7 plus x over 7, and taking the derivative of this. In this case, this method, the second method here in red, clearly would have been simpler. But you can see how the quotient rule works, and we ended up with the same answer. Tomorrow in class, you'll practice a number of these problems, and there are problems where we can mix together the product rule and the quotient rule, where you would have a product in the numerator or the denominator, or both. So you would start with the quotient rule and mix in the product rule. Clearly much more complicated than either of them together.